Well, welcome back. Our topic tonight is a review of tabular data. Now that simply just refers to data that's given to you in a table versus a graph. We're simply going to spend some time looking at some tables. So here's our first example, and we're just going to answer a lot of questions based off this one example tonight. So we're given a table. Obviously our time is in seconds, it says, and our velocity is given in feet per second. The directions simply say a rocket has a positive velocity, v of t, after being launched upward from an initial height of 0 feet at time t equals 0. So we do have an initial condition. Our height is 0 at t equals 0. So question A. Approximate the integral from 10 to 70 of v of t using a left Riemann sum, a right Riemann sum, a midpoint Riemann sum, and a trapezoidal Riemann sum with 3 subintervals of equal length. Alright, so the first thing I want you to take notice of is those bounds there. Okay, 10 to 70, that is not the entire table. So I'm just going to kind of ignore these sections here, and I'm just looking at 10 to 70. Watch those bounds. And they did tell us 3 subintervals. So I'm going to go ahead and break it up, and hopefully you're doing the same on yours. And we need them to overlap once. So there's our 3 subintervals. And let's just start with a left-hand Riemann sum. Alright, so I want to remind you, I am basically talking about a left-handed rectangle, and my area formula is base times height. So I just need to get the base and the left-handed height of each of these. Now I want to remind you, the base is your x values, the height of course is your y. When you measure how tall something is, you're looking at the y values. Alright, so I'm simply going to say for my left-hand Riemann sum, my first base from 10 to 30 is a base of 20. And the left-handed height, remember height of your y values, is 15. Plus my base from 30 to 50 is 20. And my left-handed height would get me a 30. Plus my base from 50 to 70 is 20. And my left-handed height would be 41. Okay, now this is typically a non-calculator question, so just take your time multiplying, etc., and we'll figure that answer out. Now I just wanted to remind you, because those bases were equal, you could have just said 20 times the 15 plus 30 plus 41, and that only works if you have equal bases. Alright, so we have our left hand down. Let's go get our right hand Riemann sum. Alright, so not much is changing, except instead of picking the left-handed height, we're now picking the right-handed height. So again, my area is just base times height, and in this time, I'm going to pull the 20 out because I know they all have a base of 20. Now my right-handed height, I'm looking at this interval from here to here, and this is my right-handed height, and my right-handed height. I'm just picking the numbers on the right. So 30 plus 41 plus 46. Okay, and again, I'll let you figure out the math on your own there. And I'm just going to keep chugging here. The next one is a midpoint Riemann sum. And I'm going to squeeze it in up here so we can see. My midpoint Riemann sum, okay, again, still is a rectangle, so it's still base times height. And my bases, like we said, are all 20 still. And this time, instead of grabbing the left side or the right side, make sure you grab the number in the middle. So it would be a 23. A 34, and remember I'm grabbing those heights, and a 42. Alright, so the ugliest way you can get here is using a trapezoidal Riemann sum, which is our last one. And again, I'm just going to scroll down and stick it up here. The trapezoidal Riemann sum. Now this formula is going to change slightly because it's not, a rectangle anymore. It's not base times height. It's 1/2 base height 1 plus height 2. So you see those on your quizzes all the time. 1/2 base, height 1 plus height 2. Now again, I can pull out the base of 20 because they are all equal, and only because they're all equal. And I just need to go through and add my height 1 plus height 2. So if I'm looking at this section here, height 1 is 15, height 2 is 30. So I have 15 plus 30. Okay, on this section, my height 1 is 30 plus 41. And on my last section, 41 plus 46. Okay, now, you'll recall we said there's kind of an easier way to do that when they're all equal. You could say you're 1/2 by 20, and then you could say, well, you're only going to use the end once, and you're going to use each of those middles twice. So I can say 2 times 30 plus 2 times 41 plus the 46, you'll recall. Okay, so part A hopefully covers quite a bit of our Riemann sums on our tabular data, our left, right, midpoint, and trapezoid. All right, let's try another question that goes with these. Part B. Using correct units, explain the meaning of the integral from 10 to 70 of v of t in terms of the rocket's flight. Okay, so here's what I do every time, and I really don't think you can screw this up if you write it out every time, and you're gonna see this. They love these questions. Okay, use your first fundamental that we've talked so much about and write down what you get. Okay, before you even start your sentence. So this integral is equal to, if I integrate velocity, I get the position at 70 minus the position at 10. Okay, put that on your paper first. Now we'll write a simple sentence. Okay, so this integral represents the change in, now just who is your change in? Change means subtraction. Who is your difference in? The change is in position. Again, change is what you're subtracting. It's the change in position, or what you get when you integrate velocity. In, now we need units. Underline this. You have to have your units in there. If your velocity was feet per second and you integrated, okay, you went backwards, so now you're getting that in feet, and that's what position is measured in feet, from t equals 10 to t equals 70. And that's all we need to say. It should be that simple. Finish the first fundamental, and then write your sentence based off that. Part C. Find the average acceleration from t equals 10 to t equals 70. Okay, so again, I think this is pretty straightforward. The key word that sticks out to me, well, there's two of them. The first word that jumps off the paper is the word average, and I kind of highlight that. The second I see average, I think to myself, as long as it doesn't say average rate of change, I'm going to use the normal average value formula. Okay, so again, if it says average rate of change, you apply that formula. Otherwise, use the average formula. So I'm going to say it's 1 over b minus a, the integral from a to b. And again, remember, you don't have to guess. Who do they want you to average? Read the next word. Average acceleration. Okay, now we'll apply it to this formula. So I should get 1 over 70 minus 10 would be 60. The integral of 10 to 70, and you're integrating a of t dt. Okay, now you probably know nothing about a of t, and that's fantastic. You don't need to know anything, because use your first fundamental and finish this integral off. If you integrate a of t dt, who do you get? You should be getting v of 70 minus v of 10. And now, do you need the 70 minus 10 or 60 on the bottom? Well, is it out front of this integral? Yes, so you put the 60 on the bottom here. Now, these answers should be fairly simple to find. All you got to do is look at your table. V of 70, if you look at your table, is 46, and V of 10 is 15. So let's just plug them in. So 46 minus 15 all over 60, and we'll get our answer. Now let's talk about our units. So 31, of course, there. 31 over 60. All right, now I really don't think you should be able to screw these units up. We call them dummy proof for a reason, not to insult anybody, but because they should be that simple. The 46 and the 15, look at your table. Okay, those come from, here's 46, here's 15, they happen to be on the line called feet per second. That's what that is. The 70 minus 10 happen to be on the line called seconds. So on top, you have feet per second, and on the bottom, you have per second. That gets you feet per second squared. Remember, you're averaging acceleration. If velocity is feet per second, acceleration should be feet per second squared. Question D. What is the least number of times v of t must equal 40? Okay, so here's what you ask yourself. Do you need to look at the slope, or are you just matching v of t to the table? Okay, does this match what the table says? If it does, you don't need slope. You are just simply looking at the table. And the question is, when does v of t have to equal 40? Okay, well, does it happen between those two numbers, or those two numbers? When does v of t have to hit 40? Hopefully you're saying sometime between here. And I hope you'd agree if you're at a height of 34, now you're at a height of 41, you must have hit 40. And since this function is increasing, it's only going to happen once on that interval. Okay, so right off the bat, I'm going to say once v of t must equal 40. Okay, so kind of answer the question and reply what they asked. Once v of t must equal 40. Since v of t is continuous, okay, and that had to be true, we were told that in the directions, I believe, since v of t is continuous, and now you just state where it happens. And v of 40 is less than 40, which is less than v of 50. Okay, is that a true statement? Is v of 40, that's 34, is that less than 40, which happens to be less than 41? Of course. Okay, so you don't need to say that part. I'm just reiterating to you that this number is less than 40, and 40 is less than this number. Then v of t must equal 40 by the intermediate value theorem. Okay, now notice I did not do any calculus. I simply matched the table up. When you simply match, that is called the intermediate value theorem. Okay, no calculus, no slope, you're just matching it up. Kind of the common sense rule. All right, now I'm going to switch tables on you, and I want to focus on this table, and we're just going to answer one question about it, but we did switch tables. So here's our new question. What is the least number of times v prime of t must equal 0? Okay, now let's take note. We have a table about v of t, and we're asked about v prime of t. Okay, so are you matching it up this time, or are you literally looking at the slopes? All right, so again, this is v of t, and you want v prime of t. So the first thing I said is they don't match, and I wrote down slope on my paper, just so I remember, I'm looking at slopes this time. I want to know, does this ever have a slope of 0? Okay, now, the obvious answer would be if your two y values are the same, okay, and you subtract them, y2 minus y1 over x2 minus x1, you would clearly get a slope of 0. Now, that's not going to happen all the time, so you have to use some common sense, okay? What is velocity doing? And that's the question. What is velocity doing? All right, well, let's make a, try to graph it out. Take 2 seconds and think about it. You start at 0, 2. And then at 8, you're at 4. At 10, you're at -8. At 15, you're at -6, -1, and 3. All right, so what did your v of t do? Well, it had to increase, and then it had to decrease, and then it had to increase again. All right, so let's think about this. What does it mean to have a slope of 0? Every time we set the derivative equal to 0, that implies one of 3 things. First, and let's get this in our notebook, you could have just a horizontal line. Those have slopes of 0. 2, you could have a max. Every max has a slope of 0. Or 3, you could have a min, because every min has a slope of 0. All right, so if it's not obvious, if there's not 2 points that are equal, you need to be looking for one of these things to happen. Either this whole thing needs to be flat, or you have to have a min or a max. Now again, if we just plot these points and think about what happens, this function increases, then it decreases, and then it increases again. So what is the least number of times you must have a slope of 0? Well, if you created a max, you should have a slope of 0, and a min, you should have a slope of 0. So right off the bat, I need to say twice. Okay? I should have at least 2 slopes of 0s. Now, we have to be smart on how we answer this question. Okay? First of all, I need to state the interval that this happens on. If you were just to zoom in on this section here, the function is strictly increasing. Okay, you can't say you have a slope of 0 yet until your function changes from increasing to decreasing. So I need to make that just a little bigger. Would you agree in this section, you can clearly see that your function increased and then decreased. So I can say twice and repeat the question back, v prime of t has to equal 0. And I'm going to say on the interval 0 to 10, Okay, on the interval 0 to 10, we have a max, which implies v prime of t has to equal 0. And on the interval, okay, so let's go back. When do I have a min? Bracket in a section that clearly shows you have a min. If you think it's simply this section, what did you do in that section? You went from -6 to -1, which means you increased. So that's not a min unless you change from decreasing to increasing. So if I widen this section up a little bit, -8 to -6 is still increasing. All right, so I still don't have a min yet. So I'm going to make it a little bigger here. From +4 to -8, I decreased, and then I increased. So I'm going to say on the interval from 8 to 15. Okay, make sure you can see the function has a min or a max. On the interval 8 to 15, we have a min. Okay, and again, you can say, so v of prime of t has to equal 0. How do you know you have a min? You could say v of prime of t changed from negative to positive. Here we could say we have a max because v prime of t changed from positive to negative. Okay, say whatever it takes. Now, if you looked at the slope, here's the difference, guys. If you just matched it up, it was IVT. But if you looked at the slope, we can now say this is true not because of IVT, but by the mean value theorem. All right, by the mean value theorem. And I want to recall that's the f of b minus f of a all over b minus a equals f prime of c. So if you use slope, you use the mean value theorem. All right, so that's going to sum it up for us tonight. Hopefully that was a nice quick review of tabular data and you feel pretty comfortable tomorrow. Have a great night.